Work on finding probabilities associated with the binomial distribution. And if you remember from the previous example, we were working with this setting where we were counting the number of millennials in a random sample of 20 that had a tattoo. And we were able to summarize that as x, our binomial random variable, is a counting variable with n of 20 and p of 0.38. We're going to continue with that same example to look at calculating probabilities. So the first type of probability we're going to calculate is the probability that we see exactly a certain number of successes, or x equals some number k. So in our example, out of 20 millennials, I see exactly 3 successes, or exactly 13 successes, or something like that. On our calculator, we're going to use this function binom_PDF. So I want you to associate this idea of P in PDF with equal to. And I apologize, I finally figured out why I can't write and have the calculator open at the same time. That's my problem. So I'm going to try, uses too much memory on my computer. I'm going to try these together. So here, this P for binomial PDF associate with equaling exactly a point. All right, so let's do one of these together with the calculator open, and then I might close that so we don't have all this funky problem with my pen tool here. So this first question is asking, find the probability that exactly half will have a tattoo. So the order we're going to put this in our calculator, maybe I'll just show you this first. To find it on your calculator, here's your steps here. You're going to go to second distribution. It'll be one of the distributions there. So let's pop over. So second, this blue button. Distribution, it's this vars button right here. So second distribution or vars. And you'll see lots of distributions here. Scroll down a little bit. And you should see binomial, and you'll notice there's 2 of them here, binom_PDF. That's what we're working on, the probability of equaling exactly a single point, a particular number. And then the other option is CDF. We'll talk about that in a moment, but for now, let's make sure we're on this PDF option. Press enter. And depending on your type of calculator, you may see some different things. So this particular calculator has kind of a menu to paste your information in. Trials, in this case, we have 20 trials. We have a random sample of 20. P is that probability of success, which is 0.38 in our example. And the X value is this guy. What do we want to be equal to? So in this first question, it says, find the probability exactly half will have a tattoo. So if I have a sample of 20, exactly half is the same way of saying 10 of them will have a tattoo. So I've got all the information in. I'll paste it. Now those of you that did not see a menu like that on your calculator, you'll see the home screen say binom_PDF. It's kind of cut off on the left-hand side here. And then it's up to you just to enter these 3 values in this particular order. And in your notes, you have a reminder. It goes N, P, and then what you want to find the probability of. And those need to be separated by a comma. If you have that kind of calculator, you can find the comma right here above the number 7. Okay, so enter 20, comma, 0.38, comma, 10. Press enter. And we get our answer, or our probability. Notice it's a number between 0 and 1, so this definitely makes sense as an answer. This is telling us about 9 or 10% of the time we will see a random sample of 20 people giving us exactly 10 with a tattoo. Now, hopefully you found that. If you could not find that, please don't hesitate to contact me and I'll help you kind of walk you through those steps. I'm going to close this out for now so I can write on our notes a little easier. Now, back to our notes, let's formalize that. So we've got the question, write that in probability notation. Exactly half is like saying, I want to find the probability x equals 10. We're going to use binom PDF. Again, we're thinking P because that's associated with equaling a particular point. Get those two associated with one another. And then our N was 20. Our probability of success is 0.38, and the K, or the X value we're interested in, is 10. And we saw a moment ago on our calculator the probability that we got there was 0.09735. Okay. When you're doing this in your assignments, please write it down exactly as I have here. What probability you're finding, what you entered in your calculator in this format, and then your final answer. I'll be looking for all three of those pieces of information. Don't just give your final answer. Okay, next bit, find the probability that 5 people will have a tattoo. So probability, x is equal to 5. Again, we're seeing the question is asking about exactly equal to. So we're using PDF for equal to. Our N and our P stay the same. The only thing I'm changing is my value of interest to 5. And if you want to pause, try this on your calculator. I got 0.0945 for my answer here. So these are kind of similar values, and that makes sense. If you remember, our average was 7.6 people. So kind of between these guys, a little similar on either side of the mean. So we kind of getting similar values, even though this isn't a symmetric distribution. All right, so we know how to find probabilities that are associated with equaling a particular value. Now let's look at the other type. The probability that x is less than or equal to a particular value. So this is much different than the one we did before. Less than or equal to is going to be 0 successes all the way up to that number of successes. And this is the notation on your calculator. It's the same spot you noticed we had side by side, PDF and CDF. So you're going to have to be very careful about which one you choose. CDF is associated with less than or equal to. Make a big deal of that in your notes. So less than or equal to is binom CDF, stands for cumulative. And our inputs are going to be exactly the same though. So again, keep trying this on your calculator and pause. Make sure you're getting these answers. But let's set these up here. First one, find the probability that 10 or fewer. So using our probability notation, x is less than or equal to 10. So that's finding the probability that 10 or fewer. This less than or equal to is the very definition of binom CDF. So not PDF anymore, but CDF because it's cumulative, 0 successes all the way up to 10. But our inputs are going to be the same, 20. 0.38, and we're interested in a value of 10. Before we give the answer here, let's compare to earlier when we did binom PDF with 10. When we find this answer, are you expecting a value that's smaller than, larger than, or the same as our previous answer? Right. It's going to be larger than our previous answer because it includes our previous answer of 10 successes, but it also includes 9, 8, 7, 6, 5, all the way down to 0 successes. So it includes a lot more. So we're adding up more probabilities. And in fact, you're going to get something like this, 0.9077 when you work that out. Okay, let's try a couple more variations. The next one is very similar, but this time it says strictly fewer than 10. So probability x is less than 10. So this time, less than 10, we can't use CDF yet because CDF has to be in the form of less than or equal to exactly that way. So we can change less than 10 as the same thing is less than or equal to 9. Okay, strictly less than 10 would be 9 and below since we have counting numbers here. Now we're ready to go. Since this is in the form of less than or equal to, we can use Binomial CDF. And we'll put our values here, 20.38. And be careful, this last one is 9. It should be smaller than this, and specifically we're just subtracting off the probability of 10 successes that we had before, which is going to give you 0.8103. Then finally, the probability at more than 5 will have a tattoo, so probability x is greater than 5. So we're running into the same problem here. I have a greater than sign, but to use CDF, I must get it to look like less than or equal to. So we need to flip this around first of all. You might think about greater than and less than or equal to are opposites. We're talking about probabilities, so all these should be kind of starting to ring bells or put things together here. Opposites and probabilities, that's like the complement rule. The probability of something is the same as 1 minus its opposite. That's our complement rule. So the opposite of more than 5 would be 5 or fewer. And now we're ready to go. We have this in the form of less than or equal to, so 1 minus Binomial CDF. Our inputs are the same. Our n is 20, p of 0.38, and our x we're interested in here is 5. And when you work this out on your calculator, don't forget to do 1 minus all this. Often people make the mistake of just doing Binomial CDF. Don't forget the entire problem, and that's going to give you 0.1671. Finally, just as kind of a random side note in case you're interested in this, I put this problem in here because a student requested one on tattoos one time. And just to compare to previous generations, 38 of millennials, 32 of Gen X, 15% baby boomers, 6% silent generations. You can definitely see an increasing trend as the generations develop. Be interested to see, get updated information with new generations. All right, we're going to do one more example with this. So if you want to try the next one on your own before watching the video and checking your answers.